FIFO buffers, or first in, first out buffers. They're a type of elastic storage component that connects two subsystems. Generally speaking, these two subsystems might be operating at two different speeds. So for example, we'll have a system in here or subsystem in here and another subsystem in here. And let's assume that this subsystem in here wants to communicate with the other subsystem, and it's operating at just a much faster speed. So what happened, it will be generating a lot of data points and in a much faster speed than the receiver can actually receive it. So what we need to do is we need to put some sort of a buffer in between them that can facilitate this type of communication. And FIFO buffers are used for this particular purpose. So for example, the center system would actually have a new word right here, and it will just push it to the buffer. Basically, it'll push it to the tail of the buffer or the end of the buffer. And whenever the other subsystem that is reading the FIFO buffers is reading, will basically issue a command to read, and it will just basically read the one at the head of the buffer. And as you can imagine, the name FIFO starts for first in, first out, meaning that the first word that got in, which is this one, will be the first one that will get out. Okay, so it's an order type of buffer that whatever you put in will get out first. And generally speaking, you're going to see a couple of signals. We're going to see a write signal and a read signal. The write signal is generally speaking connected to the sender system, and whenever you issue that write command, you'll effectively be writing a new word in here. On the other hand, you're going to see a read signal, and the read signal is issued by the receiving subsystem. And whenever we receive it, there's a couple of ways you actually can pick up a word out of the FIFO buffers. Okay, but basically it will be reading that FIFO buffers. And FIFO buffers are just memory components, so they will be constructed using general memory area that we have seen, whether it's BRAM or just using the FPGA fabric. So I mentioned briefly that we have a couple of ways to actually read out of a FIFO buffer, and these two words are actually based are called first word fall through, okay, or a standard FIFO buffer. So let's briefly mention what these two ways do. So we start with the first word fall through, which is this one in here. And as it turns out, the output signal, or the signal that is in the front of the buffer or the head of the buffer, will be always available without any control signal. So if there's some sort of a memory word in here, or a word that I'm interested in, it will be available directly at this output. And this is basically the first word fall through. And the reason of the name is the following. Let's assume that this buffer has been empty. So what you're going to see is we're going to be writing into it. We're going to put some sort of a data in here, and we're going to issue a write command. And what happens is the write command would write into the buffer. Of course, the buffer is empty, so the word is not going to stay here, but it will fall directly to the output. And this is why we call it fall through. So you don't need any read signal to read the output. The output here is always connected to the head of the buffer, and it will always read it regardless. So in the minute you write anything into it, it will be completely available at the output. And whenever you issue a read signal, let's assume that what happens is I have a word in here, okay, some word in here and another word in here. Of course, the word that is actually here in purple, you're going to see that it's available already in the output, and I can continuously read it. So if I want to read the following signal or the following word, what I would do is I would issue a read command in here, and what the read command does, it's actually going to remove this word in here, push the second one in, and we're going to see that this now is available at the output. So the purpose of the read signal at that point is actually to remove the head of data point, basically, and just make the next one available. So of course, if there's nothing available afterwards, it's just gonna read gibberish, meaning let's assume that this is the only word that happens in here. There's nothing else in the FIFO buffer. It's pretty much empty except for this word. If you issue a read command, what you're effectively doing is you're asking it to move to the second word, but the second word is empty, so you'll be reading whatever is stored in the memory array, even though it might be meaningless. So we're going to see later that in this FIFO buffer, we're going to have signals that will tell us whether this FIFO buffer is empty or full or whatnot, so that whenever we read something, we figure out if it's actually a valid point or not. So this is the first word fall through, the one that's actually in red. So that output is directly output of the buffer. However, there might be situations where you actually want some sort of a synchronicity in actually reading the data point. So what we're going to be using is we're going to be using the second one, which is the standard FIFO. And in the standard FIFO, what you're going to see is the first word in here, which is, I'm highlighting it in green now, is not going to be available directly on the output because the output is going to be in here. So what's going to happen is you're going to have to issue a read command first. And what the read command is, during the next clock cycle, it will store it in this particular register. And of course, the output of the register will be available at that point. So the purpose of the read signal at that point is actually to take the value from the head, put it in that register, and I will only read the output with the clock because the register is a clocked signal. It's a sequential clocked signal. And as is obvious from this figure, it is pretty simple to construct a standard FIFO from the first word fall through FIFO. All we have to do is just take the first word fall through FIFO and connect the register to its output and connect the read to the enable. And of course, we connect it to the FIFO buffer itself, and we can construct the general standard FIFO that you see in here.